All right. Well, here we are. I'm asking you to write this recursive method so that if you call it with the number 10, call down by twos with 10, it's going to print 10, 8, 6, 4, 2, 0. So basically we're going down by 2 and we're going all the way down to 0. And if you call it with an odd number, it goes down by 2 all the way down to actually 1. Not what was shown there. I'll fix that before you see it. Because it's got to be greater than or equal to 0. All right. So what we can do is put a print call in here. We're going to do print without the ln. We're going to do print n plus a space. All right. So that when you call it with 10, it's going to print the 10 in the space. And then what we're going to do is check if we should if it should call itself again. So if n greater than, I'm going to start with n greater than 0. And we're going to call down by twos n minus 2. Let's see what happens. We'll run it. It's not going to be quite right, so don't tune me out yet. The first one is going to work fine. The 10, 8, 6, 4, 2, 0. Someday. I'll just pause and resume when it starts working. Let's see. Looks like it's going to start working. There we go. Now it did the first line correctly, 10, 8, 6, 4, 2, 0, but it didn't do that. I didn't want to go to -1 on the second one. I wanted to end at 1. So we can actually just check, make sure that it's greater than 1 before we call it again. So watch this time. The 10 one will still work because 2 is greater than 1. When you subtract 2, you get 0. And now it works just as I had requested. So recursion can be easy. It can also be, really confusing. So anyway, this one, hopefully you can see, not a big deal. If you change this to -1, your numbers would go down by 1. So you'd have 10, 9, 8, like a countdown. Yeah, but anyway, the solution is I wanted it to go down by twos.